safunola with whatever we do. Haleyi demunyu skula, nyepamne ne kudlukula. Nyepangiragala gena, nyepamne ne kudlukula. Ibuloke nongoto ni beti sola. Ibuloke dato ni betoto.
Mingi Congo.
Lamin.
Na?
Lamin te jibe norin te nyamen Lamin.
Kabana wulo kono.
Wulo kono nyinta mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Lunda mana.
Mo kata.
Jamani bere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na mudu ma kontan.
Ngoto minaka ngalamin je fom filitala. Lamin jibe nori nyaala.
Lamin ida siran sama ne bengi. Yala so tol sayni no ko mo lakko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakilo diata bake karamu ngoto. Anu sainteng ministry ko di ngole si suwo ko amanke ko do holiday la
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko ina karta bulo be damna ala ni je
ngodo
nam
ngoto mon kontan fere
jamani mu nekata
ifika Lamin ki wulo ko no nyinta mon ko do fede malo Lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasita wulo ko nako
karambu wol ma ko ni ko karambu wol sorande amanke ko holiday lem ngodo dini wonyanta sila la ala karango la moy yamen kamen fue man kontaan andamande
alla nyin ko mo courant adanda lo ko mbolen do la jan karamol le soronda do kamen courant ma da do lo ko fana na karamol soronja karamol soron Lamin ada lo nyino la amanta ra fe na so kon ala mu nekela
Lamin ite foyde malon kon le sinol be ke kar radio to
nga fine
e ko yana di mo Lamin ya mu na fonye
bir kabin mina kan ntambita nteri maning Fatu ntambite la sugal ala dinol bebe siri be la moy ka
faru danso am fana tambira jele ni subala la ngaje dini ngol be jet talanta ni kili waro e be seri jele
sa Lamin fadante ku kili wo ke no la ba Lamin bi taka wulo ko no nyin taymo Lamin
amandara fenela
ite dine ko ni man si yakari la suno la moy radio to e balon nan
muneka ke afonye ba nyara ni alon
telentel jikot
afonye ba mu be ke
ite balon tel be jikritel ni man karam me ku kele yaaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin ma ñata la wulo ko aru karam mo be so da fanya membe kala
ko to wole nati ba ngalle ni Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono ibe karangol dike la radio ni telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe o kala nyaadi
kamun ke nyaadi
radio abe wala moy la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandi
ila subject ro baby jele baby jele
wala nan ka coco moy fa dan so wolya ngombe tambi kana ngadi ningol de be ikadum bungo de ko kada ma mo
asototal de
Lamin mala be karawala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko dia ko ndego folle sini lamba ndele sini lo ne ba
say mba foke en koto wole fango ye mulindi yalo famo keta bat yu fana bulata ko ko don me Lamin nyanta karana ndel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wora ka munda kara mo man soro Lamin nyanta kara si suwa na radio
la silale ayala le sino
ndal ko korno ko smolo
kilar ya
mo be ngala ko momo sa imbe do ni fano kera
mengi bruzo
ndelo ko do la da baro sa no radio ba no bari woro radio ni abe jele ba do ngamra to man nembe buljan ala nyara nyar wo fara ko fendi mo la Lamin tayra ba do sa
bara te ku folo ajibe nori nya labi tamete ku
muna na de
teku
bari ko do famo ke
imagine nani nyambol sizol le keje kisiki man sizol ndol le kafun ka nyoma bari nyambu kino li manya na kafindi ni nambe ko rozor la ga
ngalle limbeta de be nyambo do dilanna
nyara ni ko rim fennat nyara nata
bari famo ke da
ngata bungono tambi bungono nyara ngando ko fele ko ke baru nganda ni pelo la dijak
iyo awe better la
ko bismillah bisu diara
pendulala yefu ngotanka sina dolu tanka korota korota
Hi everyone, I am Mr. Babukar Rao, your chemistry tutor, and today our lesson will be based on standard enthalpy of solution. But before that, we will try and solve our assessment question together, and the question was on the standard enthalpy of combustion. And then the assessment question was, the following results were obtained from an experiment to determine the standard enthalpy of combustion of ethanol. And then we are given data. That is, initial temperature of the water is equals to 25 degrees Celsius. Final temperature of the water is equals to 50.0 degrees Celsius. The mass of water in the can is equals to 200 grams. And the mass of ethanol bond is equals to 1.0 grams. Amount of heat produced by using the ethanol to bond the wick is the same heat that raised the temperature of 200 grams of water of specific heat capacity 4.2 joules per gram per Kelvin from 25.5 degrees Celsius to 50.0 degrees Celsius. Calculate the standard enthalpy of combustion of ethanol. Now we'll using this data, and then we calculate the standard enthalpy of combustion of this ethanol. And the first thing is to identify our T1 and T2, which is the initial and the final temperature. And then these two temperatures are all given. And our T1, which is the initial, is 25.5 degrees, while the T2 is 50.0 degrees. But the standard or the specific heat capacity of water given is 4.2 joules per gram per Kelvin. The temperature in the specific heat capacity of the water is in Kelvin. So we will convert our degrees Celsius to Kelvin. Now we'll have 25.5 plus 273, and here also we have 50.0 plus 273. And now here we will use the calculator, and then we try and calculate this together. That is, we will have 25.5 plus 273, and this is equals to 298.5 Kelvin, which is our T1. And then the T2 will have 50.0 plus 273, and here we will have 323 Kelvin, that is 323, and you can confirm these answers using your calculator. Now the change in temperature, that is change in temperature. Now we have change in temperature is equals to T2 minus T1, and then our T2 is 323 minus, and our T1 is 298.15, and this is equals to 323 minus 298.5, and here we have 24.5. We have 24 Kelvin. Now the next thing to do here is to calculate the heat evolved. The heat evolved, and then the heat evolved is calculated by using MC theta. And again, we said the M is the mass of water used, the C is the specific heat capacity, and then the theta is change in temperature or rise in temperature. Now, the mass of water given in the question is 200 grams. Therefore, we'll put here 200 times. And the specific capacity of water given 0.2 multiplied by the what? Change in temperature, which equals to what? 24.5. And here, our heat evolved will be 200 times 4.2 grams of ethanol, which is C2H5OH, is equals to 1 times x. We divide both sides by what? By 1. And here our x will be 46 times 20. We have 2058, and then we will have something 9460 joules. But this value is high, so we will divide by 1000 in order to add 1 kilo, so that we will reduce this value. And here, this is the same as 94. Here we have here 1, 3. We'll have 946.7 kilojoules. Now, this is standard enthalpy of combustion. Therefore, should be what? Negative, to show that it is what? Exothermic reaction. Now, this is the standard enthalpy of combustion of ethanol regarding this question. And that's all everything about the assignment. Now, today, our lesson will be based on standard enthalpy of solution. And the standard enthalpy of solution, this is the heat released or absorbed when 1 mole of an ionic compound dissolves in 1 dm cube or 1000 cm cube of a solvent at 298 Kelvin and 100 kilopascal. And the definition we have there, heat released or absorbed, which means standard enthalpy of solution can be exothermic reaction or endothermic reaction, depending on the type of ionic compound dissolved in the water. So whenever the heat is released, it will be exothermic reaction. And whenever heat is absorbed, it will be endothermic reactions. Now note, A, standard enthalpy of solution has the symbol that is delta H. You have degree and then you have what? Solution. And that degree is signifying the temperature, and the solution is and the SOLN is signifying the solution. And B, standard enthalpy of solution can be positive or negative because heat is either released or absorbed. Or C, the heat involved depends on the concentration or the amount of the substance involved. That is, if the system is endothermic reaction, which means it is cool, the more salt you dissolve in the water, the more cooler it becomes. And if the solution or this reaction is exothermic reaction, which means as you are dissolving the ionic compound in the water, it is releasing heat and the container will be warm. So the more or the greater the amount of the ionic compound dissolved in, the greater the heat evolve. And here we have determination of standard enthalpy of solution. That is, calculate the standard enthalpy of solution of potassium hydroxide from the following data. And then we are given mass of KOH, which is mass of potassium hydroxide, equals to 5.6 grams. And then the initial temperature of the solution, which is T1, is equals to 25 degrees Celsius. The final temperature of the solution, which is T2, is equals to 38 degrees Celsius. And the mass of water used when dissolving this salt is equals to 100 grams. And then the specific heat capacity of the water is equals to 4.2 joules per gram per degree Celsius. Now, as you can see in this case, the specific capacity of the water, one of the units there is per degree Celsius, which means there will be no need for us to convert the initial and the final temperatures from degree Celsius to Kelvin, but we can just subtract directly and find our change in temperature. And then here we have the solution, and then we will solve this together. That is, the first thing here is to calculate the heat evolved. Now here, we want to calculate the rise in what? Temperature. That is, the first thing to calculate is rise in temperature. And this rise in temperature can be calculated using the difference between what? The initial and the final temperature. And then our final temperature was 38 degrees Celsius minus, and our initial is 25 degrees Celsius. And here we use calculator. That is, we have 38 minus 25, and then we have 13. Therefore, the rise in temperature in this case is 13 degrees Celsius. After calculating the rise in temperature or the change in temperature, we calculate evolve. Heat evolve. Heat evolve is always calculated by using MC theta. And again, we said the M is for the mass of the water, and the C is for the specific heat capacity of the water, and then theta is for what? The temperature. And the mass of water used in this reaction is 100 grams times the specific capacity of the water is 4 point times. The theta there is the change in temperature or rise in temperature is degree. And here we have 100 times 4.2 times 13, and then we will have 5, 4, 6, 0. The amount of heat evolved in this reaction. Now, the question said 5.6 grams of KOH was dissolved in 100 grams of the water, which means this is the amount of mass, or this is the amount used, and this is not equivalent to the what? 1 mole of KOH. So therefore, in this case, we will calculate the standard enthalpy of solution, saying if 5.6 grams, that is 5.6 grams of KOH, that's what dissolved in the water, produces 56 or 5460 joules of heat. Now we'll calculate the equivalent of what? 1 mole of KOH in mass. That is down there, and then we know that equals to 39, oxygen is equals to 16, and hydrogen is equals to 1. Now if you want to calculate, we will say 39 1 decay plus oxygen is 16 times 1, and again we have hydrogen 1 times 1, and here we'll have 39 plus 16 plus 39 plus 16 plus 1, and then we'll have 50 per mole. And this means in every single mole of KOH, grams. In every of KOH, there is what? 56 grams. So here we will say, therefore, 56 grams of KOH will produce X joules after supply. And this 56 grams is equivalent to what? 1 mole of KOH. If you cross multiply 56 times 5460, which will be equal to 5.6 x. We make exterior the formula by dividing both sides by 5.6. 5.6. And this 5.6 will cancel this. For x will be, we'll have 56 460 divided by 5.6, and here we will 54600 joules. And this value now, so you can divide by 1000 in order to add kilo, and then this number will be reduced, and then therefore we'll have this 1, 2, and 3. So the point will come to this end, and then we'll have 54.6 joules. And then this is standard enthalpy of solution. So we said it could be endothermic or exothermic, depending on the initial and final. Now our T2 is 38 and T1 25, which means T2 is more than what? the T1. As the reaction is going, the temperature is increasing, which means this system is evolving. So therefore, this will be example of what? Exothermic reaction. If was greater than T2, it means this at the state it is getting cooler. So therefore, we'll put here positive sign and then we'll have endothermic as our final answer. But here the system is exothermic because T2 is greater than T1. And you must include this negative sign when you are writing your final to show the system is exothermic reaction. Without this negative sign, your answer is wrong. Now, on the board, the same thing. Temperature rise is equals to 38 minus 25. And then the 38 is the T2 and the 25 is the T1. You subtract, you have 13 degrees Celsius. Now the heat change is calculated as MC theta. The M is equals to 100 and the C is equals to 4.2 times. The theta is 13, that is change in temperature or rise in temperature. Now, after calculating 100 times 4.2 times 13, we have 5,460 joules. And this 5,460 joules is produced by 5.6 grams of KOH according to the question. Now, to calculate the standard enthalpy of solution, say 5.6 grams of KOH produces 5,460 joules of heat. Therefore, 56 grams of KOH, and this 56 grams of KOH is equivalent to 1 mole of KOH, and this will produce X joules of heat. Now X will be 56 times 54, that is 5,460 divided by 5.6, and then we will have 54,600 joules or 54.6 kilojoules. That is divided by 1,000 and then your answer will be in kilojoules. Hence, the standard enthalpy of solution is minus 54.6 kilojoules. And that's our final answer for this question. Now, our assessment question is 4.0 grams of ammonium trioxonitrate 5, that is NH4NO3, is dissolved completely in 100 cm cube of water in an insulated container. That is insulated container, there will be no heat loss. The temperature of the water falls from 23 degrees Celsius to 17 degrees Celsius. The temperature is going down. And this is actually telling us something about this question. Looking at this initial temperature and the final temperature, you can determine whether this system is endothermic reaction or whether this system is an exothermic reaction. Calculate the enthalpy of solution of ammonium trioxonitrate 5. And you are given a clue. And the clue reads hydrogen is equals to 1, which is the relative atomic mass of hydrogen. And for nitrogen, we have 14. And for oxygen, we have 16. And C, which is small c, and this small c represents the specific heat capacity of water, and is equals to 4.2 joules per gram per Kelvin. Now, that was everything about our assessment. So try and follow the other steps so that you will be able to answer this assessment question. So stay tuned for our subsequent videos so that we will answer this assessment question together. So by the way, I am Mr. Babakar Aw, our chemistry tutor. So goodbye.
Have your say.
Fellow Gambians,